One of my viewers, Raphael, asked me what I thought about Anne Reardon's video debunking the myth that dark baking sheets brown better than light baking sheets. If you are not familiar with Anne, she is the creator behind How to Cook That channel. I don't normally watch it, but the topic of baking sheets is near and dear to my heart, so I decided to take a look. The reason Raphael sent it to me is that he watched my video on baking sheets. You know, that one where I demonstrate that a grungy, old and dark baking sheet browns better than a new and shiny one. Raphael noticed that Anne's experiment brought her to a completely different conclusion and was wondering why. Oh, Raphael, you have no idea what you just unleashed on poor Anne. I'm sorry, but this is going to get ugly. For her test, Anne buys all sorts of baking sheets: aluminum, stainless steel, carbon steel, and glass. Some are deep, some are shallow, some are slightly bigger, and some are slightly smaller. Some of these baking sheets happen to be dark and some happen to be shiny. Anne bakes the same cake recipe in them for the same amount of time, at the same temperature, and compares the results. Okay, pause this video and think. Is this a good way to prove that the color of the baking sheets doesn't matter? No, it's not. Anne's baking sheets have way more differences than just their color. They're made out of different materials. They have different thicknesses and different depths. If you change this many variables, how can you possibly conclude anything about the color? Say I want to debunk the myth that black clothes make you feel hotter in the sun than white clothes. Here's my debunking test. I stand in the sun for 5 minutes in a black t-shirt. Then I stand in the sun for 5 minutes in a white fur coat. In my test, I don't feel hotter wearing black than white. Thus, I conclude that the color of the clothes makes no difference to how hot I feel in the sun. That's absurd, right? Well, Anne's experiment is equally absurd. But wait, it gets better. As we keep watching Anne's video, we'll learn about another brilliant experiment, the ice cream test. Anne puts ice cream on different baking sheets at room temperature to see which baking sheets would melt the ice cream the fastest. This is supposed to test the conductivity of the baking sheets. Anne says that the ones that are the best conductors would brown the fastest. Unfortunately, we don't bake things on the counter, we bake things in the oven, where conductivity is only one variable. The other one is radiation. Glass is the worst conductor out of the ones Anne tested, and it melts ice cream the slowest. But in the oven, it browns better than some of the metal pans because it lets more radiation through. Does Anne notice? Seems like she doesn't. Here's the conclusion of her testing.
You really can't see much difference between them.
Really, Anne? I can see a good bit of difference between this one and this one. In her debunking video, Anne changes multiple variables, pan materials, dimensions, and color, measures the wrong thing, conductivity instead of browning, and doesn't report the data accurately. She says that there is no difference in browning when there obviously is. The fact that none of Anne's viewers called her out on this is sad, but not surprising. I mean, I haven't read every single comment. There were like 3,000 of them. But I haven't seen anyone raise any questions about Anne's testing methodology. If I posted that video on my channel, I think my viewers would raise hell, and rightly so. Compared to normal YouTube audience, you guys are brilliant! It's tempting to go into a nice little rant here about the state of science education in our schools, but let's be realistic. Scientific method is not intuitive. It's completely contrary to human nature. We all make such mistakes. I'm sure I do too. But one thing that helps me deal with this challenge is being aware of the typical pitfalls and the way that my brain can trick me into believing a fallacy. To demonstrate more such pitfalls, let me tell you about my latest pasta experiment inspired by your comments. Recently, I made a video on 4 different methods to make pasta dough. In that video, the dough that was kneaded by the mixer came out stickier than the dough that was kneaded by hand. So many of you wrote to me with your hypothesis for why this happened. And the most common one was that my wood counter was absorbing the moisture from the dough, while the stainless steel mixer bowl was not. There were also some ideas about my hands absorbing the moisture from the dough. I'll be honest with you that it never occurred to me until you mentioned it. This sounded like a very reasonable explanation. If you are right, this could be tremendously useful. I could figure out how much moisture gets removed during hand kneading, and then I could warn people that if they were letting the mixer do all the work, they could simply reduce the water by that amount. I made 3 batches of dough. I used the mixer to bring the wet and dry together for all the batches. I weighed the dough right after the wet and dry came together, and it was 490 grams. Basically, it's just the sum of all the ingredients. Then I kneaded it in the mixer on low speed for 8 minutes and weighed it again. It was 488 grams. It only lost 2 grams. For the second batch, I kneaded by hand, but since I don't have a stainless steel counter, I used a large stainless steel skillet. I weighed the dough when it was done, and it was 486 grams, so it lost 4 grams of water. For the last batch, I kneaded by hand on the wood counter, and the final dough weight was 488 grams. So it lost the same amount of moisture as the one that was kneaded in the mixer. The difference between all these batches was so small that it could be attributed to a scale error or the tiny bit of residue left on the bowl or on my kneading surface. In case you don't have an intuition for grams, 1 teaspoon of water weighs 5 grams. So the 2-gram difference we've observed is less than half a teaspoon. And wasn't it surprising that the dough kneaded on wood weighed the same as the dough kneaded in a mixer? In case you want to repeat this experiment at home, I want to clarify that I'm not kneading on an oiled wood cutting board. It's a wood counter that is treated with a special protective coating. I don't know if an oiled cutting board would behave exactly the same. The long story short is that unfortunately, I can't confirm your hypothesis. It doesn't look like the difference in the dough is due to the moisture removal during hand kneading. Although we can't use this experiment to make my pasta recipe more specific to different kneading methods, we can use it to learn something interesting about the scientific method and human psychology. Humans seem to be incapable of observing an effect and not coming up with some cause. We love cause and effect so much that it's like a knee-jerk reaction. That's not a terrible thing, as long as we keep it clear in our head which things were empirically proven and which things just sound like a good idea. This problem gets greatly exacerbated by introducing academic-sounding terms like proteins, molecules, ions, and enzymes. As soon as they introduced, people automatically trust the idea because it sounds scientific, even if there is no empirical basis for it. When the food writers whip out the scientific jargon, I usually get more skeptical rather than less. Cooking systems are quite complex. Cooks don't have any tools for observing molecules, enzymes, etc. We read about them in the books and then we project the behavior of one component of the system onto the whole system. Sometimes it works and sometimes it doesn't. I would take a well-designed experiment over some theoretical knowledge of chemistry any day. Cooking is similar to sociology. Sociology is a study of how humans behave in groups, and obviously that is governed by the human brain. But few sociologists dissect brains because it's not all that useful to the questions they want to study. Having a scientific mindset in the kitchen doesn't mean that you need to brush up on your high school chemistry, but it does mean that you need to brush up on the scientific method. Another psychological pitfall is confusing correlation with causation. I'll give you an example. When I was doing this past experiment, I took the temperature of the dough after kneading it by hand and after kneading it in a mixer. The dough that I kneaded by hand had an internal temperature of 69 Fahrenheit, and the dough that was kneaded in the mixer had an internal temperature of 73 Fahrenheit. Wouldn't it be tempting to conclude that the reason the mixed dough is sticky is because it's warmer? But that would be a mistake. All we've seen is a correlation between a warmer dough and stickiness. We know nothing about causation yet. To tease out correlation from causation, we'd need to set up another experiment where the only difference is the temperature. I would have to knead my dough by hand in a 69-degree kitchen and then crank up the thermostat and knead another batch by hand in a warmer kitchen and see if that makes a difference. Just because two things are observable at the same time does not mean that one causes another. When I started doing these sorts of test videos, I got lots of comments from people asking me to just get to the point and stop explaining all the details of my experiment. I think by now all of them have unsubscribed and only the smart people are left because the comments have gotten better. You see, the media people know that their audience has no patience and just wants the bottom line. This creates a great distortion in how scientific findings are reported. Most experiments don't show anything earth-shattering. If you read any scientific study, it usually shows that changing the variable X results in some small change in the variable Y. It's too hard for the general public to wrap their head around these little differences. They want a good story, a dramatic story. They want to hear that drinking green tea can prevent breast cancer and eating fish can damage children's brains. If you want to understand something, don't ask for the bottom line. Ask for the experiment design and the data, and then you can draw your own conclusions. Here is another dose of culinary skepticism for you, and if you are ever in the Boston area, maybe I'll see you in one of my classes.